Hello everyone. Today we're going to talk about the quotient rule for differentiation. And so we're just going to describe the quotient rule for differentiation, and we'll give a couple of examples using the quotient rule. So the quotient rule is given as follows. It's actually fairly similar to the product rule. So if f and g are differentiable at x, and if g of x does not equal 0, then so is f divided by g, and the derivative of f divided by g is just the derivative of f times g minus the derivative of g times f all over the g squared. So let's look at a first example here, where this is our f of x over g of x. And so the product rule says that dy dx is the derivative of the top the derivative of 2x squared plus 5 times the bottom, 3x minus 4, minus the top, so 2x squared plus 5 times the derivative of the bottom, the derivative of 3x minus 4. And that is all over the bottom squared. So let's compute the appropriate derivatives. So the derivative of 2x squared plus 5 is just 4x. That's times the 3x minus 4 minus the derivative of 3x minus 4 is just 3. I'll do that first. And then that's times the first, the 2x plus 5. And again, that's all over 3x minus 4 squared. Again, at this stage, you'd probably distribute the 4x, and you'd distribute the minus 3, and you'd collect some like terms. And when you do that, in the end, you end up with 6x squared, and then you end up with minus 16x's, and last but not least, you end up with minus 15. You may want to verify this fact, and then that's all over 3x minus 4 quantity squared. So a slightly more complicated example is where your numerator and your denominator aren't just polynomials, so you don't just have a rational function, maybe you have some trig functions like sine x over x squared plus sine x. But the product rule is still the same. So the derivative of y with respect to x will be the derivative of the top, which is the derivative of sine x, which is cosine x, times the bottom, which is x squared plus sine x, minus the top, the sine x, times the derivative of the bottom. The derivative of x squared plus sine x is 2x plus cosine x, and that is all over the bottom squared. And there's not much simplification that's going to go on here, other than you can see this cosine x sine x and this minus cosine x sine x are going to cancel. And so in the end, you're just going to get x squared times cosine x minus 2x times sine x and that's all over. It's still that same denominator squared. And that gives us the derivative of our rational function, which had signs in it. So that brings us to the end of our quotient rule video, and we covered our objectives. We talked about the quotient rule for differentiation, and we gave a couple of examples using the quotient rule. Thank you very much, and I hope you have a wonderful rest of your day.